Imagine a future where Earth is no longer a safe haven, and humanity must look beyond the stars for survival. Among the countless planets discovered, one world stands out: Proxima Centauri b, or simply Proxima b. At just 4.3 light-years away, it is the closest known exoplanet that might support human life. But while it may seem within reach, the journey to Proxima b is a challenge beyond anything we have ever faced. It would take centuries of innovation, engineering marvels, and a complete redefinition of space travel to turn this distant world into our new home. Proxima b orbits Proxima Centauri, a red dwarf star that is significantly smaller and cooler than our Sun. One major advantage of this is that red dwarf stars have exceptionally long lifespans, burning their hydrogen fuel at an incredibly slow rate. This means Proxima b could potentially remain habitable for trillions of years, far surpassing the expected lifespan of our own Sun, which is predicted to expand into a red giant and eventually engulf Earth in about 5 billion years. Unlike our Sun, which burns through its fuel at a relatively fast pace, red dwarfs offer a far more stable and enduring environment for potential life. Given this extended timeline, Proxima b presents itself as a compelling candidate for human colonization in the distant future. However, this longevity alone does not guarantee habitability, and other critical factors such as its atmosphere, surface conditions, and radiation levels must be thoroughly examined before considering it a viable home for humanity. As Earth continues to face environmental challenges and the looming certainty of the Sun's eventual transformation, exploring alternative planetary homes becomes not just a scientific endeavor, but a necessity for the survival of our species. However, not all exoplanets are suitable for human life, and most of the worlds we have discovered so far are either massive gas giants like Jupiter or Neptune, hostile infernos, or barren wastelands with extreme conditions. Of the thousands of exoplanets detected, only a fraction are terrestrial like Earth, and an even smaller number fall within their star's habitable zone, where conditions might support life. Proxima b stands out because its orbit lies in this coveted region, raising the possibility that it harbors liquid water, a fundamental ingredient for life as we know it. This discovery alone makes it one of the most compelling candidates for exploration and potential colonization. Scientists theorize that if it possesses an atmosphere rich in greenhouse gases, temperatures could be stable enough to sustain liquid water, making it one of the most promising relocation options for humanity. However, many unknowns remain. The composition of its surface, the presence of an active magnetic field, and the intensity of stellar radiation from Proxima Centauri could all determine whether this planet is truly habitable or merely another lifeless rock in the cosmos. Despite these uncertainties, Proxima b continues to fuel hope and curiosity, pushing scientists to explore the limits of what is possible in humanity's search for a new home. The journey to Proxima b, however, would be an extraordinary endeavor. Even though it is our closest neighboring exoplanet, the distance is still immense. Traveling at the speed of light, the journey would take over 4 years. Unfortunately, with our current space technology, the fastest spacecraft would take roughly 165,000 years to reach Proxima b. To make this relocation feasible, we would need revolutionary advancements in propulsion systems. Some theoretical proposals include nuclear fusion propulsion, antimatter engines, and even warp drives inspired by science fiction. Without these breakthroughs, the time required to reach Proxima b would span thousands of human generations. Beyond the technological challenges, the human aspect of such a journey poses complex issues. If a spaceship were to transport people to Proxima b, its passengers would spend their entire lives in transit, with many never seeing Earth again or ever setting foot on their destination. Generations would be born and die in space, adapting to an artificial environment that could significantly alter their physiology, psychology, and culture. Studies on long-term space travel suggest that prolonged exposure to microgravity leads to muscle atrophy, bone density loss, and weakened immune systems. Additionally, the psychological strain of isolation, confined living conditions, and the knowledge of an unending journey could lead to unforeseen social and mental health challenges. Another major concern is the genetic diversity required for a sustainable population. According to some calculations, at least 98 individuals would be needed to maintain a healthy gene pool and avoid problems associated with inbreeding. This would require careful planning in terms of crew selection and reproduction strategies, ensuring that future generations have enough genetic variation to thrive. The social dynamics of such a small, isolated community would also be critical, necessitating measures to prevent conflicts and maintain psychological well-being over multiple generations. Additionally, ensuring a reliable food and water supply for thousands of years would be another immense challenge. A self-sustaining biosystem capable of functioning indefinitely in deep space would need to be developed, incorporating advanced hydroponic farming, water recycling, and oxygen generation. These systems would have to withstand potential failures, cosmic radiation, and unforeseen complications that could arise over the centuries. Without a robust ecosystem that can continually regenerate resources, survival on a generational spacecraft would be impossible. The entire mission would rely on humanity's ability to create an artificial environment that mirrors Earth's life-sustaining conditions as closely as possible. Even if humanity manages to overcome these obstacles and reach Proxima b, the planet itself may still be inhospitable. One of the biggest unknowns is whether it has an atmosphere that can support human life. While its location in the habitable zone suggests the possibility of liquid water, there is no guarantee that Proxima b has the necessary conditions for human survival. It could be a frozen wasteland with surface temperatures dropping as low as -40 degrees Celsius -40 degrees Fahrenheit, or it might lack a protective magnetic field, exposing its surface to deadly cosmic radiation from its parent star. Additionally, Proxima b may be tidally locked, meaning one side always faces the star while the other remains in eternal darkness. This could result in extreme temperature differences that make habitation difficult. Given these uncertainties, some experts believe that rather than attempting to relocate to a distant exoplanet, humanity should focus on building megastructures closer to home. Concepts such as space habitats, artificial planets, or even Dyson spheres, massive structures that could harness the energy of an entire star, might offer more practical solutions for long-term survival. By developing advanced space stations or colonizing planets within our solar system, we could create sustainable human settlements without the need for interstellar travel. While the dream of reaching Proxima b is an exciting prospect, the reality is fraught with immense technical, biological, and ethical challenges. The journey would require groundbreaking advancements in propulsion systems, self-sustaining life support, and human adaptation to the harsh conditions of deep space. Even if we were to overcome these hurdles and successfully land on Proxima b, there is no guarantee that the planet would be as habitable as we hope. It could lack a stable atmosphere, suffer from extreme temperature fluctuations, or be bombarded by lethal radiation from its parent star, making survival a constant struggle. Rather than investing all our efforts into reaching an uncertain world, perhaps the wiser path is to focus on improving Earth and expanding human presence within our own solar system. Space habitats, advanced colonies on Mars or the Moon, and large-scale space stations could offer a safer and more achievable solution for humanity's long-term survival. By harnessing cutting-edge technology and sustainable practices, we can build a future where we thrive without the need for interstellar travel. The future of humanity may not lie on a distant, unknown exoplanet, but in our ability to innovate, adapt, and protect the world we already have. But if we are to secure our place among the stars, we must act now, whether by preserving Earth or pushing the boundaries of space exploration. The choice is ours, and the time to decide is now.